Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello, ladies and gentlemen. It's such a pleasure for me to be presenting here in front of all of you. First of all, let me introduce myself in behalf of my team members. My name is Rizkan Nur Miftahul Ulum. With this research team is Mr. Berkah Fajar, Mr. Tony Surya Utomo, and Mr. Ridwan. We are all part of Mechanical Engineering Department, Diponegoro University. In addition to that, Mr. Berkah Fajar is also part of Undip Training Center, Energy Conversion, Diponegoro University. In this occasion, I will present to you our research result which titled Experimental Study of Performance AC Split Retrofitting R32 to R290. Here are the outline of our presentation today. We will start with the introduction, methodology, result, and last but not least is the conclusion. Introduction. One of the environmental issues of this century that is attracting the world attention is global warming and the destruction of the ozone layer. One of the main cause of damage or depletion of the ozone layer is hydrochlorocarbon and chlorofluorocarbon, which have a higher ozone depletion potential value toll. R290 is natural material that has zero ozone depletion potential and low to negligible global warming potential. It is not harmful to the environment. The only problem with R290 is that its high flammability can lead to hazardous incidents if not handled properly. In Europe and some Asian countries, R290 has been successfully used instead of R22 in heat pump, where its performance is satisfactory and the risk associated with its high flammability are well controlled. This is methodology or research. Some formulas to calculate performance air conditioning. There are refrigeration effect, how much work compressor, heat transfer in condenser, and last coefficient of performance. The experiment apparatus, a split type air conditioner unit with a cooling capacity of 1 pk serve as the experimental equipment. Compressor, condenser, evaporator, and capillary tube are the parts of a split air conditioner. The condenser and evaporator are fed in a duct after this major component is detached from its original design. Compressor, condenser, and evaporator performance data are easily accessible thanks to the component connection to the refrigerant pipe. Temperature and pressure are recorded on its component. From the refrigerant leaving the compressor, the mass flow rate of refrigerant is the system is calculated. The compressor power is determined by measuring the electric current, voltage, and power factor it requires. Condenser inlet and outflow temperature and relative humidity. These measurements are used to figure out how much heat is transferred between the condenser and evaporator. Computer, DIK, and temperature sensor are example to data acquisition and measuring instrument. The experiment was carried out in two parts, with the first step using a split AC field with R32 and second step using R290. The experiment began with a mass of R32 of 430 grams. Experiments were conducted with an ambient temperature of 30 Celsius, at room temperature of 23, 25, and 27 Celsius, with another ambient temperature of 35 Celsius at room temperature of 25 and 27 Celsius. In line with the hydrocarbon filling reference, R290 is filled with 60% or 258 grams of the total mass of R32. The measurements were taken after the system had been stable for 60 minutes, with a 5 minutes delay between its measurement. The experiment begins with a mass of 430 grams. Following the completion of refrigerant R32 data collection system. Next is result. In this figure, compass R32 cooling capacity to R290. Cooling capacity is a measurement of a cooling system ability to dissipate heat or the predicted output of the air conditioner. The sooner the room temperature rises to the required level, the greater the cooling capability. Due to a reduction in compression work, R290 has a lower cooling capacity than R32. This indicates that the power consumption of the refrigerant R290 compressor is lower than that of the refrigerant R32 compressor at all room and ambient temperature. This is due to fact that R290 has a lower mass than R32. Because the compressor work become lighter, less power is required. The coefficient of performance refrigerant R32 and R290 are shown in this figure. A drop in COP may be seen in the diagram. Overall, the result reveals that the COP of refrigerant R290 is lower than the COP of refrigerant R290 for all room and ambient temperature condition. The COP value of its refrigerant used in affected by the cooling capability and power consumption of R32, which is larger than that of R290. The result of this study showed that the use of refrigerant R290 retrofitted R32 with a mass of 60% and variation in temperature of room temperature and ambient temperature saw a 35% decrease in power consumption from R290 to R32. The cooling capacity of R290 has decreased by 33.50% from that of R32 because the cooling capacity is low, thus affecting the compressor lower power consumption. There was a decrease in COP from R290 to R32 of 20.01%. Overall, the performance of using refrigerant R290 has not been maximized to replace refrigerant R32. That's all that I can present to you, and thank you for your advices. Wassalamualaikum warahmatullahi wabarakatuh.